We want to determine the second derivative of the given function, and notice the given function is a quotient. So in order to determine the second derivative of the function, we need to find the derivative of the first derivative. So the first step is to find the first derivative of the given function. So if we let the numerator equal f and the denominator equal g, we can determine the first derivative by applying the quotient rule given here in red. And then once we find the first derivative, we can find the derivative of that function to determine the second derivative. So to determine the first derivative, we'll start with the denominator. Notice how the denominator is just the denominator squared, or g squared. So we'll have 4x plus 3 squared in our denominator. And then we'll have g, or the denominator, 4x plus 3, times the derivative of f, or the derivative of the numerator, which will be 3, minus the numerator, or f, which is 3x minus 1, times the derivative of the denominator, or the derivative of g, which will be 4. Now let's go ahead and simplify this numerator. Here we'll have 12x plus 9. And here we'll distribute the 4, so we'll have 12x, but we're subtracting that, so minus 12x. Here we'll have minus 4, but we're subtracting that, so that'll be plus 4. So 12x minus 12x, that's 0. So our first derivative is going to be equal to 13 all over the quantity 4x plus 3 raised to the second. Now our goal is to determine the second derivative, which means we need to find the derivative of this function here. So we can avoid having to apply the quotient rule if we move this up into the numerator, which will change this exponent to negative 2. So we'll have 13 times the quantity 4x plus 3 raised to the power of negative 2. And now we have a composite function. So if we let u equal the inner function, we can rewrite this as 13 u to the power of negative 2. So now we can apply the extended power rule, which includes the chain rule, to determine the derivative of this with respect to x. So our second derivative is going to be equal to the derivative of 13 u to the negative 2 with respect to x. So we're going to multiply by negative 2. That's going to be negative 26. Subtract 1 from the exponent, it's going to be negative 3. So this would be u to the negative 3, but u is 4x plus 3 times u prime. Well, if u is equal to 4x plus 3, u prime is equal to 4. So here's our second derivative. Let's go ahead and rewrite this. Negative 26 times 4 is negative 104. And then we can think of this quantity as being over 1, so we move it to the denominator, the power becomes positive 3. So our denominator would be the quantity 4x plus 3 raised to the third power. This would be our second derivative function. I hope you found this example helpful.